Okay, Longhorns, the next topic we're going to take a look at is dividing polynomials using long division. So this part we're going to do in class, and I'm also doing the video so that you can go back and review it so that you have something to follow while you're doing your homework and practice problems. All right, so let's do this warm-up problem first. We have a number divided by another number, and we're going to just go back to grade school for a few minutes and perform this long division. All right, so traditionally we have a symbol that we use as just a division symbol. We put our dividend inside the division little house here, and we put the number, which is called the divisor, on the outside. Now what we're going to do is a division operation where we're going to multiply some number times 6 to get 15. So we need to decide how many times 6 will divide into 15. Well, 6 will divide into 15 twice. So I'm going to put a 2 above the 5 in my 15. Now I'm going to multiply the 2 times 6. That's going to give me 12. And then I'm going to subtract. When I subtract 12 from 15, I get a 3. And now I drop down the next number that I have in my dividend. I just drop it down. Then I decide how many times will 6 go into 39. Well, it will go 6 times. 6 times 6 is 36. And then I subtract again. This time I have a 3. I'm going to bring down the 7. Again, 6 can go into 37 6 times. 6 times 6 is 36. And I'm going to have a remainder. Now this remainder number is going to be a fraction. And so we're going to take the remainder that we have and we're going to put it over the divisor. So our final answer is 266 and 1/6. All right, let's try another one. Now if you've already done these in class, you don't have to do these again. Just fast forward through this video to the parts that you need to see. But I'm going to go ahead and do this division as well. We have 7,349 divided by 12. So how many times will 12 go into 73? Well, it'll go in 6 times. That leaves me with a 72 minus 14. 12 goes into 14 one time. Bring down the 9. 12 goes into 9 twice, with a 5 remaining. So my answer is going to be 612 and 5/12. And that's it. All right, so how does this apply to polynomials? Well, we're going to use the same algorithm, the same steps to divide polynomials. So as I told you before, factoring is just a fancy word for dividing. So before, when we were doing factoring, we were just dividing the polynomial into its factors. And so we're going to do that again, except this time we're just dividing the polynomial into a primary factor and then another polynomial. So you'll see what I'm talking about when we do one. Let's go ahead and go to the examples. Okay, so some things to remember when dividing polynomials. Polynomials must be in standard form. You have to fill in any zeros for any missing terms. So your polynomial has to be in polynomial order, like x to the third, x squared, x, and then a constant. The remainder goes over the divisor, just like we did in this other division problem. And we have to line up the terms in the appropriate place values. So let me do one example, example number 1, and then I'll show you example number 2, and then I want you to do example 3 and example 4 on your own. Now I'm going to do example 1 down here at the bottom of this page because long division takes up a lot of space. It takes a lot of paper. So when you are working on your homework problems, you're probably not going to be able to do them in your book. You're probably going to have an extra sheet of paper to add to your notebook to work these division problems because they are quite lengthy. So let me start with number 1 and I'll show you what I mean. Okay, so I've rewritten my division problem. This right here is my divisor. This is my dividend. I'm going to get my quotient, which is going to be above the dividend with the remainder if we have a remainder. All right, so the way we're going to do this is just like we did the other one. So how many times does x, and we're just going to look at the x. We're not going to look at the 5 right here yet. It'll come into play here in a minute. But what we're looking at is how many times does this x go into this x cubed. So we know that this x can go into this x cubed x squared times. So how do we know that's x squared? Well, we know that because x squared times x is x to the third. So not only do I need to multiply my x squared times x, I need to multiply my 5 times x squared. All right, so I did this multiplication. X squared times x is x to the third. And then I do the 5. X squared times 5 is 5x squared. Now I'm going to subtract. So what you need to remember when you subtract is you're subtracting both of these terms from your dividend. So let's go ahead and subtract those. Now x to the third power minus x to the third power is just going to be 0, so we don't need to write anything down. But 11x squared minus 5x squared is going to give me 6x squared. And now I'm going to do it all over again. How many times will this x go into this 6x squared? Or you could also say, what would I need to multiply times x to get 6x squared? Well, I need to multiply a positive 6x. So now I'm going to do my multiplication again. I'm also going to bring down my next term, which is my 39x. And then I'm going to multiply 6x times x, and that's going to give me 6x squared. And then I'm going to multiply my 6x times my 5. 6x times 5 is 30x. And then I'm going to subtract again. And when I subtract, 6x squared minus 6x squared is just 0. And then I have 39x minus 30x, which gives me 9x. And then I'm going to bring down the 45. Okay? Now, how many times will x go into 9x? Or what number do I need to multiply times x to give me 9x? Well, I need to multiply that times 9. So 9 times 9x is 9x. And 9 times 5 is 45. And guess what? When we subtract this, we get no remainder. So our final answer is this. When I divide x cubed plus 11x squared plus 39x plus 45 divided by x plus 5, I get x squared plus 6x plus 9. Now let's take a look at number 2. I'm going to go ahead and erase what I've written here because I want to show you what to do with number 2. So I'm going to go ahead and erase this, and then we're going to start with number 2. All right, so for problem number 2, We have x cubed minus 27 divided by x minus 3. So I'm going to set this up. I'm going to put my x cubed, except if you'll notice that there's no x squared term and there's no x term. When this happens, you have to put in what we call placeholders. So you have to put in something in there to hold that place. So we're going to put a 0x squared in there. We're also going to put a 0x. And then we're going to put in our minus 27. So when you're doing long division like this, and also when we get ready to do synthetic division here in a little bit, you have to put in these placeholders where we don't have a value for that term in our polynomial. So we didn't have an x and we didn't have an x squared, and since we have to go in polynomial order, we need to include those spaces. So we're going to put placeholders in, and that's what we do. We just make it a 0x squared and a 0x. Then I make my divisor the x minus 3, and then I start my division. So x will go into x to the third x squared times. X squared times x is x to the third. And then x squared times a negative 3 is a negative 3x squared. And then we subtract. So I'm going to get x to the third minus x to the third is just 0. And then 0 minus 3, you have to be careful here though, because this is actually 0 minus a negative 3, which is, so watch out right here. Watch out for this double negative. This is 0 minus a negative 3, which is the same thing as 0 plus 3. That's why I use parentheses when I'm doing these subtractions. You probably noticed that I put parentheses around here before I subtract, and this is why. Because if you have a negative sign in front of here, and then another minus sign here, this is actually minus a negative. And so this is actually going to be adding. So 0 plus 3, so we end up with 3x squared. And then I bring down my next placeholder, which is my 0x. And then I do the division again. X goes into 3x squared. That's going to happen 3x times. So 3x times x is 3x squared. And 3x times a negative 3 is a negative 9x. Now that's not a 10, that's a 0. Okay, don't get confused about that. All right, so put my parentheses around there, put my minus sign in front, and I subtract. So 3x squared minus 3x squared is 0. 0, here we got it again, minus a negative. So this is going to actually be 0 plus 9. So I put in my 9x. And then I bring down my last placeholder, and don't forget this negative right here. This is a negative 27. So when I bring it down, don't forget to bring down this negative sign. Because if you forget it, then it's going to be wrong. Your answer is going to be wrong. So make sure you're not dropping any negatives. Negative 27. And then we do the division again. So x goes into 9x. That's going to happen 9 times. 9 times x is 9x. And 9 times a negative 3 is a negative 27. And then we subtract. And so 9 minus 9 is 0. And negative 27 plus 27, see how this is a plus? Negative 27 plus 27 is 0. So we have a remainder of 0 again. So far we haven't had any remainders. So probably in class we're going to have to do one of those so that you can see what a remainder looks like. Let's move on to synthetic division. Okay, in your notes it tells you that for polynomial division, synthetic division, that the same principles as long division apply as far as the dividend has to be in standard form, missing terms need to be marked as zeros, and remainder goes over the divisor. So those all still are the same, whether you're doing synthetic division or long division. Okay, some other things that you need to know is that for synthetic division, the linear divisor has to be an x minus r form. Okay, the x needs to be a degree 1 polynomial, and it also has to have a leading coefficient of 1. So 1 and 1. If this x is not that, then you can't use the synthetic division. All right, so you can also have a minus r or a plus. So this right here could be plus or minus. It doesn't have to be minus. It could be plus or minus. You just have to remember to change the sign. Okay, then we're going to solve for the factor. We're going to use x equals r. In other words, when you get ready to do the division, you're going to use the opposite sign of this. All right, so let's try practicing with number 1. I'm going to go ahead and expand this page so we've got some room to work. Okay, so synthetic division is a little quicker and easier than long division, but it only works, remember, when you have a divisor in this form. If your divisor is not in this form, x plus or minus some number, then you can't use synthetic division and you have to use long division. All right, so let's start with our dividend. The way we're going to do this is we're going to make a box, and in the top row it's like a 2-row box. In the top row we're going to put all the coefficients that are in front of our variables, and we're going to also include our constant. So we have 1, -2, -22, and 40. Now notice that I left some space right here. I left some space right here because we're going to be putting some numbers right here along here. So we need to make sure we leave some space. Now on the outside over here, I'm going to put the opposite of this number. So this is -4, so I'm going to put the number 4 right here. And that's the number I'm going to use for this algorithm. All right, so the first step is just to bring the first number straight down. So we're just going to bring that number straight down. And now we're going to start our algorithm. All right, so the first thing we're going to do is we're going to multiply 4 times 1. And we're going to put that number right here. So this is a multiply. 4 times 1 is 4. And now going down, we're going to add. So -2 plus 4 is 2. Okay, then we're going to do it again. 4 times 2. 4 times 2 is 8. -22 plus 8 is -14. Then we're going to multiply one more time. 4 times a -14. That's going to be a -56. And then we add again. So 40 plus a -56 is a -16. All right, so what we need to do is we need to determine what these numbers represent. This last number down here, the -16, that's our remainder. So if you notice that in our polynomial, we started with x cubed right here. This answer, this polynomial answer that we have right here is going to start 1 degree lower than this polynomial leading term right here. So x cubed, this one's going to be x squared. So I'm going to go ahead and write down this x squared, and then I'm going to have an x term, and then I'm going to have a constant, and then I'm going to have my remainder. So the numbers that are down here, these numbers right here, are my coefficients. So the first one's just x squared, 1x squared. The next one's going to be plus 2x. The next one's going to be minus 14, that's my constant. And then I have a remainder of -16. And so I'm going to write minus 16 over my divisor. My divisor was x minus 4. And that's my answer. So as you can see, the synthetic form for dividing doesn't take up as much space as the long division, but you can only use it if you have this type of divisor right here with x by itself and then a plus or minus some number. That's the only way you can use synthetic division. Let's do one more example. Okay, I'm going to do number 3 this time. And first of all, I notice right away that my polynomial is not in order. This is going to be a problem when I get ready to do division, because my polynomial degrees need to be in descending order, and right now they're not. They're kind of mixed up. So the first thing I need to do is rewrite my polynomial in the correct order. Okay, so as I was writing my polynomial, I noticed that I have an x to the 5th, I have a minus x, 5x to the 4th, I have a plus 6x to the 3rd, but I don't have an x squared. So remember what I said about that. You have to put in a placeholder for anything that's missing. This one is missing an x squared. So we have to put in a 0x squared in that spot. Then I have my 5x, and then I have my minus 15. Now I have all the pieces I need to do my synthetic division. So I'm going to make my box, and I'm going to put all my coefficients in order in my box. So I have a 1, a negative 5, a 6, a 0, a 5, and a negative 15. The divisor that I'm going to use is the opposite sign of x minus 3, which is going to be 3. And then I just start my algorithm. So I'm going to bring my 1 down. So the first one's going to be 1. Then I do 3 times 1 is 3, and I'm going to write that here. 3 times 1 is 3. And now I add. Negative 5 plus 3 is negative 2. Then I do it again. 3 times negative 2. 3 times negative 2 is negative 6. And then I add. So 6 minus 6 is 0. Then I do it again. 3 times 0 is 0. And then I add. Well, I'm just going to get another 0. And then 3 times 0 is 0. And then I add again. This is going to be 5. And then I multiply one more time. 3 times 5 is 15. And when I add, I get a 0 remainder. So on this particular polynomial, I'm not going to have any remainder. Okay, so let's see. We started with x to the 5th. We started with x to the 5th. So this first term is going to be x to the 4th. And then we're going to go down from there. X to the 4th, x to the 3rd, x squared, x, and then our constant. Okay, so we have a 1 for our first term, a negative 2 for the second term. We don't have a third term. We don't have a fourth term. And then we have a plus 5 for the last term. So I'm going to rewrite this so that it looks like a regular polynomial without all the zeros. So we have x to the 4th minus 2x cubed plus 5. And that is all. And we're finished. All right, so we're going to be doing lots and lots and lots of practice. We practice Friday all day, and then we're going to practice on Monday as well, finish up some problems. I'm going to give you a list of problems that I want you to do, and you need to write those down or take a picture and make sure you've got those down or circle them in your book so you know which ones to do, because we're not doing every single problem in the book. We're only going to do certain ones. So I'll let you know which ones those are in class, and just need to mark them down or circle them, and those are the ones we're going to be practicing in class. So good luck with the long division, and I hope that you get a very good handle, a very good grasp on this topic.